Hi everyone, welcome to my channel. In this video, I built my childhood dream ship with all the options you can dream of. Since I had so much fun with the boat that I built almost 3 years ago and that I had some ideas for a new one, I wanted to build the ultimate utility ship, and it was about time I get it done. Because I want to cover so many details, I need to tell you that this is the first part of a 2-part series. Part 2 will be out soon. I wanted this new boat to be the same size as my first one. That means that I would have to downsize the original design. It must have a boat thruster, so I'll add one. I also want a lot of lights, enough to land a plane or to blind a seagull. I want a watertight hatch. I want a rotating and functional fire monitor, a functional winch to tow, and a functional A-frame who would serve for rescue missions at my local club and more. And finally, I want to add a captain, so no one asks me why I didn't add one on my first build, because apparently people lose sleep over captainless RC boats. Man overboard! Enough talking, let's start the build. I decided to make the rear part of the deck a little different for 2 reasons. I wanted better access to the inside and I wanted it watertight. I came up with this design that I've tested on my other boat. The whole deck felt flimsy, therefore I added an extra layer from below. I simply downscaled the original design in the slicer and adapted it to my needs. This is the watertight hatch I'm talking about. It's printed in TPU. The frame for the hatch is printed in ASA like the rest of the boat. Here I'm making ASA slurry. It's made from ASA filament or scrap pieces and acetone. Since acetone melts ASA, it's like soldering pieces together. The hull was made to be printed in 3 parts, but my printer couldn't do it due to its size, even though I scaled it down. So I printed it in 5 sections as big as my Prusa MK3 allowed me to. Here is how the bow looks like at 100% size in comparison to my print bed. It's frustrating to acknowledge that almost all the warping and cracks you see could have been avoided by using glue stick on the print bed. Yes, I knew it. Yes, I ignored it. And yes, I paid the price. Another big problem occurred during the print of the stern. The extruder idler broke due to the heat in the enclosure and caused some bad layers. Later, these would let water in the hull. It's almost impossible to print big parts out of ASA or ABS without any warping. At least I couldn't do it. And I have an enclosure to keep the ambient temperatures high, and I bought some glue sticks later during the build. It helped, but it still wasn't like printing PTG or PLA. But since there's a solution for every problem, I used the heat gun to make the hull straight again. It took a while, but was worth it. If you know something about brushless motors, you've noticed that the shaft points out what's normally the rear. I had to modify the motor because there was not enough space to install it otherwise. Problems didn't stop there, because I had to make the shaft hole bigger for the stern tube. I made a real mess, see for yourself. Warning, the next scene contains graphic content. There wasn't enough space for the propeller between the rudder and the hull. That's why I cut this little part. I drilled some holes for screws. Due to the warping, the hull had some tension in it, and those screws would hold it in position while the ASA slurry dried. If you want to integrate my hatch into your boat, you must cut off the rear part of the original deck. This can be done in the slicer. In my opinion, a boat of that size absolutely needs a boat thruster, and that's why I added one. The tube for the boat thruster was printed with 100% infill, so it would be watertight. And I made the tube a little longer than needed, because it's always easier to remove some material later than to add some. For mental health reasons, I stopped counting the hours of sanding. I sanded so much, I think I now qualify as a beach. And at that very moment, I was sure that I was done with sanding and filling holes. But I was so naive. In the slicer, I removed 1.5 mm from the bottom of the control center to give me some space to glue the windshields. Then I enlarged the holes for the LEDs. I simply used lettuce containers. Then I designed some screens for the control center, assembled this wooden bench, a world map, and a coat for the captain for bad weathers. A fire extinguisher, and finally the captain himself spilling some coffee. Because even plastic captains need caffeine. I had to install resistors for the different LED colors. I simply followed the calculations that my brother made for my other boat and electrical diagram I made back then. Instead of buying electrical wires, I took apart a phone cable and got a lot of different colors. These wires were perfect for the job. These were the first days of my Christmas holidays, and I got excited after 2 months of building. I wanted to get some colors on my ship. Little did I know that the hull wasn't watertight and that I would have to remove a lot of paint. Because I glued the roof of the wheelhouse but still wanted access to the inside, gluing everything wasn't a good solution. By adding those little pieces, I can now use screws to install it and remove it. I designed those mast supports to make a cleaner job. Printing the mast wasn't easy at all, mainly because my printer decided it had artistic differences with the project. That gave me the motivation I needed to design my own version. This mast-like receptacle is also a creation of my own. Feel free to use it. Make sure to remove the paint before gluing the railings. These are fragile, and I will probably change them for brass in the future. Here, I modify an existing design for the searchlights. I think it was an important detail to add to the ship to make it look more complete. Deck lights are also important, and I added those two, and later I will add two more on the A-frame. These are the lights that will be on all the time. The searchlights are on a switch. Safety is important. And this crane too, even if it doesn't move. Now I need to finish some details, starting with these bollards that I painted and glued to the deck. Then I came up with the idea of using this pallet design and adding these magnets to make them fit to the TPU cover. Now I want a final and cleaner version of the stand that I designed at the beginning of the build. Since the ship comes without a stand, I used my retro engineering skills to design my own one. I achieved this by cutting the hull in the slicer and by taking a print screen that I could use as a reference. I printed the parts and used some tent hoops that I cut to the right size. Then I used Gorilla Glue to glue these caps in place. And finally, I added these TPU parts to make everything smoother. It's not perfect, but it does the job. And you can download it for free. Now let's get back to the lights, because we weren't finished. Since I like to look at my ships even when they are not in the water, I installed those batteries and this little switch to be able to turn the lights on whenever I want. Normally, the lights can be controlled from my transmitter, but I also can connect them to those batteries. I think it's a nice little detail because it brings the boat to life even when the Canadian waters are hibernated for almost 5 months. But what I like even more is that I get to admire my boats with the lights on every night while performing my usual nighttime maintenance. Then I give the boats a good night kiss, turn off the lights and go to bed feeling strangely satisfied. If you think that's weird, you're probably right. My girlfriend agrees with you, but she still loves me. Somehow. Now it was time to test the watertightness of the hull, as I was getting eager to see the boat in action. I was quite disappointed to find that a lot of water was getting in. To accurately identify the leak, I poured water into the hole. I started by sealing what seemed to be the only spot where water could get in, but it wasn't enough. I ran another test and realized that water was also entering elsewhere. I could feel the weak spots with my fingernails. I ended up making over 20 holes. It was discouraging. One of the possible solutions to this problem might have been to buy high-quality filament. That, and maybe not having printing issues in the first place. Also, thickening the vertical walls of the model might have helped, but I left the default slicer settings untouched. After more than 10 or 15 hours of gap-filling therapy, things seem okay. I used slurry, putty, and finally actual body filler. Let's just hope it's watertight for good now. Then it was time to install the rudder. I designed this part to fit a shaft collar. Then I enlarged the hole in the servo arm because I wanted to use M3 screws, and flattened one side of the rudder shaft to improve contact. I painted it and installed it, making sure to apply some Loctite on the shaft collar screws. Et voila! Finally, the weather was good outside, and now that I was confident that no more water would get in my ship, I painted it again. Then I added these white stripes and cut out some vinyl on our Cricut for the final touches. And stared at my work for a couple of minutes. I had no time to lose and wanted to get it ready for the official maiden voyage. I want to see how it handles on the water, assuming it doesn't instantly become a submarine. I temporarily added those little bags, filled with lead shot for the ballast. I will make something permanent in the next video. I'll also go into more detail about all the electronics, and I'll share a connection diagram so you can build your own overcomplicated floating machine. Also, the list of all the parts I used is already available in the description, because I care, and because I know someone will ask me in the comments anyway. You may think this is the first time I've launched a boat, but this is the third time. Still, I've put on some music worthy of the end of an action movie to get you in the mood. The boat seems stable, which is promising. I can't wait to install the boat thruster, the fire monitor, the winch and the A-frame. Next week I'll probably be able to shoot some action of an RC boat rescue mission and a firefight. I can't wait to show you all this, and it's coming up in the next video, which will be out in a few weeks' time. To make sure you don't miss anything and to encourage me, subscribe to my channel. To finish this video, I wanted to show you the footage of the nightmare that I narrowly avoided while trying to put out the marks for our regatta. The two cameras that I mounted on the wheelhouse rocked the boat as I turned, and I started to accelerate, not really knowing what was going on. The boat didn't sink, but I lost the wheelhouse. Fortunately, the electrical wires for the lights were connected in the hull and I was able to drag the boat to shore. All's well that ends well. Thanks for watching, see you in the next one.